Hello and welcome to a Venion video. As I mentioned last week, I'm not going to be here Monday or Tuesday of this week. So the plans for Monday and Tuesday basically is for you guys to work on a packet called Circular Motion 3. It's basically dealing with some of the mathematics of circular motion, practicing drawing free body diagrams, calculating net force, calculating acceleration, all that good stuff. The second thing that you'll be doing is on Tuesday, I'm going to have the sub showing a video dealing with some modern physics topics. So hopefully you find that interesting. On Friday, I had introduced a lab called centripetal force, and I had said you guys were going to be working on that on Monday and Tuesday. As the day progressed on Friday, I could just tell students weren't getting the results that they were supposed to be getting by doing this lab, and sometimes in science things just don't work out as you had hoped. And with me not being here Monday and Tuesday, I have a feeling this lab is just going to lead to a lot of frustration. And so what I'm going to say is just don't do the centripetal force lab. If you actually check the homework board, you'll see that that lab has been crossed off. You can just throw that piece of paper away, unless you want to come in sometime after school and do it or whatever. Do not do the centripetal force lab. It's not going to be an assignment. We're just going to pretend it never existed. Okay, so don't worry about that guy. Okay, so if you'd be so kind as to take out the Circular Motion 3 worksheet, I'm going to do a few example problems with you guys just to give you a feel for what you'd be needing to do in this assignment. Basically, you're using the mathematics of circular motion, so some of the new formulas that we've been throwing in from the previous week, along with some old stuff from before. So some of the old stuff from before that we'll probably need to use is F net equals ma. We also probably need to use weight equals mg. There are some questions that deal with friction, so the force of friction equals mu times the normal force. And then, of course, our newest formula dealing with acceleration, which is a equals v squared over r. Okay? Those guys, I think, are going to be relatively important on various problems on this assignment. So let's take a look at the first question. It says a bucket of water that has a mass of 3 kilograms is attached to a 0.6 meter long string and spun in a vertical circle. The water at the top of the circle's path is 4 meters per second. Okay? And they want you to basically solve all this stuff. The first one that I think would be easiest to solve for is F grav. Okay, because F grav is just the force of gravity, and I'm just going to use this weight formula to figure that out. So the mass of the bucket is 3 kilograms, and if I multiply that by g, which is 9.8, and you do that math problem, I get a force of gravity of 29.4 newtons. Okay, so we just did one. The second thing that I think might be useful to figure out is what is the acceleration of the bucket. So the acceleration of the bucket, we're going to use this formula right here, a equals v squared over r. The velocity of the bucket is 4 meters per second, and that is squared, over the radius, which is 0.6 meters. If you take 4 squared divided by 0.6 meters, I get an acceleration of 26.7 meters per second squared. And they ask for a direction because an acceleration is a vector quantity, and so the acceleration of any circular motion object is going to be towards the center. So if this is at the top of the circle, it would be directed down. Now that I have the acceleration, I have a feeling I could figure out the net force acting upon this bucket if I use the acceleration I just calculated times the mass that they give me of the bucket, which is 3 kilograms. So if you take 3 times 26.7, I get an F net of 80.1 newtons. And the net force is always directed in the same direction as the acceleration, so that too would be directed down. Now I realize I'm flying through this really fast, but this hopefully will just kind of give you a grounding in how to solve these problems, and you can take your time on some of the other ones. Now you may say to yourself, well, how do I figure out the tension force? Okay. Well, the tension force is going to be working in combination with F grav. So the way to solve this is you need to take the net force and subtract it from F grav, and whatever's left over, that's tension's job, basically, to pull this bucket towards the center to keep it moving in circular motion. So if you just take 80.1 minus 29.4, I get a F tension of 50.7 newtons. Okay? 50.7 newtons. And that's actually the first one that's done for you. Okay? So hopefully that wasn't horrible, but that's an example of the type of problem you'll be dealing with, and a lot of the other ones on this page are kind of doing the same exact thing. Just be careful. You don't always take the net force minus gravity. Like in this case, right here, gravity is in the opposite direction of the net force. So F tension has to overcome the gravitational force. So F tension is actually going to be bigger than F net. And as you solve the problem, hopefully you'll see that, and that'll make more sense than what I'm saying right now. But that's how you're going to be doing some of these. So they're not all the same. You have to do some thinking. I'm moving on down to, let's take a look at letter G. It's dealing with this car going around a circle, and it has some blanks in it with friction and mu and all that stuff. So this seems like it could be an interesting problem, to say the least. It says a 900 kilogram car makes a horizontal turn at 15 meters per second around a curve with a radius of 32.5 meters. And they say calculate some stuff about it. Okay. Well, I think the easiest thing to start with is probably calculating F grav. Okay, because remember, weight equals mg. So I'm going to take the mass of the car, which is 900 kilograms, times 9.8. And if you do that math problem, I get a force of gravity of 8820 newtons. 8820 newtons. Now, this is a flat surface, so who's going to balance out the gravitational force? Well, it's probably F norm, right? This car isn't going to start to float up or move down through the earth, so it has to be balanced out, and so F norm also is 8820 newtons. So I think the next thing to figure out would be the acceleration acting upon the car. Now remember, acceleration is v squared over r. The velocity of the car is 15 meters per second. We'll take the square of that, divided by r, which is 32.5 meters. And if you do this math problem, I get an acceleration of 6.9 meters per second squared. And what direction would that be? Well, if this is the circle that the car is traveling in, it's going to be towards the center because the acceleration is center seeking. And so I would say that looks like the right to me. Now that we have that, we can figure out F net, right? Because we know the mass of the car and we know the acceleration. So F net equals ma. The mass of the car is 900 kilograms. And the acceleration is 6.9 meters per second squared. So just take 900 times 6.9, and I get an F net of 6230.8 newtons. And the direction of the F net is always in the same direction as the acceleration. And so that would be to the right also. Now the question becomes, well, what's the force of friction, right? Well, the force of friction actually is the centripetal force in this problem. It is the thing that's allowing the car to make this turn. And so the force of friction is F net. All right, that sounds crazy, but that's the truth. So now you know the force of friction. Cool. What about mu? Well, if you remember your formula for force of friction, which is force of friction equals mu times the normal force, I have the normal force and I have the force of friction, so now it's just basically plugging numbers in. So it's 6230.8 equals mu times the normal force, which is 8820. And if you do that division problem, I get a mu of 0.7. Remember, mu is unitless, so you just leave it as is. Okay. So a little bit tougher problem, absolutely, but I think within your reach, if you just kind of think it through and again, use each other to help each other. And if you're still struggling, I'm planning to have some time on Wednesday to field questions on this. So circle things that you're confused about, and we'll absolutely talk about it. One more problem that I thought would be worthwhile to go over. Actually, I lied. Two more problems that I thought would be worthwhile to go over. Let's take a look at down on the next page. Number 2, determine the minimum speed at which ... And the hint is, at this speed, the object becomes a projectile. So 2A says the rider on a coaster car feels weightless at the top of a 4-meter loop. Okay, how do you solve this? Well, one thing we can kind of think about is if at this speed, it's the car actually is almost not physically in contact with the track anymore. It's a projectile, which this is extremely dangerous. But the car right now is actually not in contact or just barely in contact with the track. And so think back to projectile motion. What is the acceleration in the down direction on all objects that are projectiles? Well, the answer is 9.8, right? So the acceleration is 9.8 meters per second squared. Because right now it seems like this problem doesn't give you enough information. It just tells you that the radius is 4 meters. But we can make this assumption that the acceleration is 9.8 meters per second squared because it is acting as a projectile. So they're wondering, what is the minimum speed? So they're wondering, what velocity would that be that would allow this to happen? Well, if we think back to our formula, A equals v squared over r. I know A, it's 9.8. and I don't know v squared, but I'm hoping to find it, and I know that the radius is 4 meters. So basically, if you just cross multiply 9.8 times 4 and then take the square root of it, you would find that the minimum speed at which this would actually be possible is 6.3 meters per second. Now, as I was making my answer key, I realized I did not give you a mass of this car, so there is no way to figure out F grav. Don't worry about that, and that's the same for this problem here too. Do not worry about that blank. I'm not going to grade it because as of right now, you guys do not have enough information to solve for F grav. Right. Let's do one more problem that I think could be interesting in terms of challenging you guys. It's number 5 on the very back page. Number 5 says, a 54 kilogram roller coaster passenger is moving so fast over the crest of a hill that she is lifted off her seat and the safety bar exerts a downward force upon her body to keep her in the car. The speed of the car is 24 meters per second and the radius of curvature is 30 meters. Determine the downward force applied by the safety bar. Okay, I'm just going to write some things down that I know about this, and it says begin with drawing a free body diagram, and so I absolutely will do that because I think that's a good idea. But the mass is 54 kilograms, the speed or the velocity is 24 meters per second, and the radius of curvature is 30 meters. Okay, we're wondering what F applied is, okay, because you have to imagine there's like this little safety bar here that's going to stop little Sally from flying off this roller coaster. Okay, so, and also you can kind of think like this hill is kind of like a circle in a way. All right, well, that's one of my best drawn circles in a long time. So if I were to draw a free body diagram acting upon this car, think about the questions, here. What direction would the force of gravity be pointing? Well, the force of gravity would be directed down. Now, this car is actually going so fast that it's actually kind of like flying off the road in a way, as is little Sally. But there's this safety bar here, so that's touching little Sally, and so that's going to be F applied, we'll call it. F applied. Now, the length of my arrows don't really have a lot to do with this. I just was running out of space, but I just wrote F applied and F force of gravity. Those are the two forces acting on her, trying to pull her back down towards the center of this circle, okay? So the first thing I'm probably wanting to do is figure out what is the acceleration on this car. And the acceleration, or the formula for it, I should say, is v squared over r. And I think we have enough information to solve for this. So v squared would be 24 squared over the radius, which is 30 meters. So if you take 24 squared divided by 30, you get an acceleration of 19.2 meters per second squared. Okay. Well, now I think I should figure out the net force acting upon this car. Now remember, F net is ma. So if I take the mass of this car, which is 54 kilograms, and the acceleration, which is 19.2 meters per second squared, I get an F net of 1,036.8 newtons. Okay, so all I do is I multiply the mass of the car times the acceleration that we just solved for, which is right here. Okay. So that's these two forces, the force of gravity and F applied, must add up to 1,036.8 newtons because they're both pointing in the same direction, right? So they're on the same team, if you will. They're going to try to both help make this car come back down towards the center of the circle. Well, which force could I solve for first? I think the easiest one to solve for first would be the force of gravity because I can't really solve for F applied right now unless I know the force of gravity. So remember, the force of gravity is weight equals mg. The mass of the car is 54 kilograms. The g is 9.8. If you take 54 times 9.8, I get a force of gravity of, let me just quickly change colors here, force of gravity of 529 newtons, about 529 newtons. Okay, so what's F applied, or FAP, as really so affectionately like to call it? If you take the F net minus the force of gravity, I get about, this is about 508 newtons, and that would be the answer. 508 newtons of force is being applied to her legs or wherever this bar is situated on her to basically push her back down towards the center of the circle. I wish you guys the best of luck on this. I will see you on Wednesday, and as I mentioned earlier, feel free to circle questions that you're confused about, and we can talk about them on Wednesday. See you guys later.